AI data centers now consume more electricity than mid-sized cities, and the grid cannot keep up. AI rack power density has reached 240 kilowatts. Traditional data center racks run at 6, a 40x gap in power demand per rack. Transformer orders are booked through 2028. Grid connection queues stretch 3 to 5 years. Then NVIDIA did something unusual. It invested $3 billion in Lancium, a data center power infrastructure company. The largest GPU maker on Earth concluded it cannot rely on the grid to keep its own hardware running, from building chips to backing power plants. That tells you where the bottleneck has moved. The bottleneck moved from silicon to electrons. Now it is moving again, from electrons to physics itself. Elon Musk said 99.99% of compute will eventually move to space. An extreme statement, but the direction is worth understanding. SpaceX is building Starmind, satellites that do not relay data, they process it. Orbital servers powered by uninterrupted solar radiation, cooled by vacuum radiation instead of water and cooling towers, zero land cost, zero permitting, zero community opposition. The question is no longer whether orbital compute is technically possible. The question is whether it can become economically scalable. And who captures the value if it does? SpaceX controls the entire chain. Starship launches the satellites. Gigasat Factory builds them. Starmind runs the orbital compute. Starlink connects the output to customers. XAI consumes capacity for Grok. One company, 5 links, 0 handoffs. This is what a closed-loop position looks like. No value leaks between suppliers. No margin loss to intermediaries. No dependency on someone else's launch schedule, someone else's chip supply, someone else's network. The financials confirm it. SpaceX Q2 2026. Total revenue, $7.8 billion, up 92% year over year. The AI line item, $2.56 billion in quarterly revenue, up 247% year over year. Customers include Google and Anthropic, not future contracts, current revenue. AI infrastructure capital expenditure surged from $749 million a year ago to $15.83 billion in a single quarter. SpaceX is no longer just a rocket company monetizing satellites. It is building an integrated AI infrastructure stack around launch, compute, and connectivity. Now, Terafab, the chip factory in Grimes County, Texas, 9.3 million square meters. First phase investment, $16.8 billion. Full build-out, up to $119 billion. Intel 18 process node, Foveros advanced packaging, and the allocation that matters. 25% to Tesla Optimus, 75% to spacecraft AI. Musk confirmed this himself on August 6. 75% is not a technology judgment, it is a capital signal about which position captures more value now. Orbital Compute has paying customers, $2.56 billion a quarter of them. Optimus is at the flat bottom of its S-curve. Musk called it the hardest product to scale ever. Capital voted with the allocation. The bottleneck was energy. Orbit solves it. The bottleneck was cooling. Vacuum solves it for free. The bottleneck now is not technology. It is position. Who controls enough links in the chain to capture the value that flows through it? Here is what most Western coverage misses. China was first. First does not mean advantaged. May 2025. The three-body computing constellation, 12 satellites, Zhejiang Laboratory and ADA Space. The world's first orbital computing constellation, operational before SpaceX announced Starmind, November 2025. ADA Space deployed Alibaba's Qwen 3 large language model on a satellite, first general-purpose LLM running in orbit, end-to-end inference under 2 minutes. July 2026. 2 launches on the same day, Chengguang 1, an 8-card compute server running DeepSeek and other common models, Beijing's first orbital compute node. And Yunjian Muxi, carrying a domestic Muxi GPU through real space conditions, first Chinese AI chip validated in orbit. Ada Space, based in Chengdu, has filed for a Hong Kong IPO. Valuation, approximately RMB 11.5 billion, roughly $1.7 billion. 2025 revenue, RMB 700 million. Net loss, RMB 256 million. The Star Compute Plan, 2,800 computing satellites, 2,400 for inference, 400 for training. Deployed across dawn-dusk, sun-synchronous, and low-inclination orbits. Partnership with SenseTime for a 1,000-satellite space compute constellation. First launch 2026. Full deployment by 2035. Zhejiang Laboratory. 10 AI models already deployed in orbit, including an 8 billion parameter remote sensing model and an astronomical time domain model. 6 intersatellite laser links validated. Target: 1,000 satellites with 1,000 POPs of compute by 2032. Cosmospace, backed by the Chinese Academy of Sciences, designing a 10,000 GPU orbital supercomputing cluster. 3 modular components. A 100 megawatt energy module with flexible solar arrays. A 10 terabit per second communication module with 100 laser links. A 10 exaops compute module with 10,000 high-performance GPUs. The Yulong 810 chip, domestic aerospace-grade AI processor. 72 TOPS, under 6 watts. 22 nanometer FD-SOI process, radiation hardened. Operating range, -55 to 125 degrees Celsius, already batch deployed on the Qianfan constellation, over 100,000 hours of zero-failure orbital operation. On-orbit intelligent processing reduces bandwidth consumption by 90%. CAICT estimates China's space compute industry will exceed RMB 250 billion, roughly $36.6 billion, by 2030. China has submitted ITU applications for over 203,000 additional satellites across 14 constellations. The technology is real, the firsts are real, chips are in orbit, models are running. But technology and position are not the same thing. First mover in technology is not first mover in value capture. Wang Shangguang, dean at Beijing University of Posts and Telecommunications, said this: SpaceX can pull the entire chain together by itself. Chips, rockets, satellites, payloads, applications. Then sell compute through the same network, generate revenue, reinvest. Closed loop. In China, the opposite. Everyone does their own thing. Small, weak, scattered, slow. Not a technology gap, a capital structure gap. In China's space sector, rockets sit with state-owned entities. Frequency allocations sit with different state-owned entities. Launch sites with yet another set. No single company can simultaneously build rockets, manufacture satellites, operate a constellation, sell compute, and reinvest the proceeds. The ownership structure makes the closed loop structurally impossible. Value leaks at every handoff. Rocket builder to satellite builder to constellation operator, operator to compute seller. Each handoff is margin lost and coordination friction. ADA Space plans 2,800 satellites but cannot control its own launch schedule. The Yulong 810 works flawlessly in orbit, but the company that built it does not control the constellation it flies on. The Prometheus space cloud platform serves enterprise customers, but does not own the compute nodes it runs on. Liu Yaoqi of Cosmospace said it directly. Whoever first completes the technical system, infrastructure, and application ecosystem will hold the initiative in the future space information industry. The initiative requires a closed loop. The capital structure prevents one from forming. That is not a failure of execution. It is a constraint of architecture. The same capital structure that prevents a commercial closed loop also creates something SpaceX cannot replicate. And that is where most analysis stops. It should not. The same capital structure that fragments commercial value creates a different position advantage, strategic capital patience. Beidou, China's satellite navigation system, approved in 1994, 26 years of continuous state investment, no quarterly earnings pressure, no venture capital exit timeline. Global Constellation completed in 2020, now competing with GPS for global market share. That position was built by capital that did not need each step to be self-sustaining, 26 years. 0 quarters where the project needed to justify its existence to outside investors. SpaceX captures value across a commercial chain. China's orbital compute ecosystem captures strategic position through capital patience. 2 different positions, 2 different value capture models, 2 different capital pathways. The closed-loop commercial position excels at selling orbital compute as a cloud service. B2B revenue, Google and Anthropic as anchor customers, market-driven pricing, fast feedback loops. The value capture is immediate and measurable. The constraint is that every link must pay for itself. No link gets subsidized. The loop is either profitable or it breaks. The strategic capital position excels at building infrastructure that serves national capability goals. Navigation, remote sensing, communication resilience. The value capture is measured in strategic optionality, not quarterly revenue. The capital horizon is measured in decades, not quarters. The constraint is that commercial value leaks at every handoff. No single entity captures enough margin to self-fund the next cycle. Neither position is superior. They are shaped by different capital architectures. And capital architecture is not a variable you optimize. It is a given. You invest within the structure you have. Technology gets attention. Position decides return. In the last episode, we looked at the pharma scale trap. Companies buying revenue before the patent cliff, scaling without position. The same pattern shows up here. Scale without a closed loop is just spending. Whether you are a drug company buying pipeline or a space company launching satellites, the question is the same. Does your position capture the value that flows through it? Orbital compute is the same technology everywhere. The physics works, the chips fly, the models run. But the capital architecture behind it creates two radically different positions. A closed-loop commercial entity that captures value at every link. A fragmented ecosystem that leaks value at every handoff but commands strategic capital patience that no quarterly earnings cycle can provide. Neither is better or worse. They are different positions. Position decides the return path. The next repricing comes when orbital compute moves from concept to capacity. 2027 for first prototypes. 2029 for scale. Right now is the position window. The capital structures are already set. The question for investors is not which technology wins. The technology is the same. The question is which position you can access and whether your capital horizon matches the return path that position requires.
Technology creates possibility, capital decides where value is captured. Drop a comment. Do you think orbital compute will be captured by closed-loop commercial players or by strategy capital with patience? I read everyone. If this reframed how you see space infrastructure investing, subscribe and hit the bell. New episodes every week. Next episode, AI data centers running at 80% availability, fluctuation in hardware, a 2.6 gigawatt campus deployed a year. NVIDIA investing billions in power infrastructure. The foundation is cracking under its own weight. We look at what happens when the AI build out hits the liability wall. Subscribe and hit the bell. See you then.